So good afternoon, everyone again, and thank you all for joining this workshop on simulation process data management. My name is Matthijs Pont, and I will be your host together with Melissa. Melissa is sitting next to me. Don't think you can you can see her, but we will be hosting this workshop for you, which will be about an hour on, as I said, simulation process data management aimed at the beginner level. So today with us is Keith Dunlop. Welcome, Keith. Thank you for joining as well. And just to give you an overview, you can ask questions in the Q&A window on the right. If you've got Teams installed, you've probably got a bit more functionality available, but it should be available as well on the web version of Teams. If it doesn't work, you can always send us an email. I will put this up again at the end of the meeting, matthijs.pont@insumma.nl, and the same email address for Melissa, of course. And if after the session you'd wish any more info, you can always ask us via email, or of course go to the website mscsoftware.com. So Keith, without further ado, let's switch to you and let's see how the world of simulation process data management can be explored from a beginner level.
Okay, thanks very much. So hopefully you see my screen. Yours?
Yeah, I can see it.
Okay, perfect. So you see a slide introducing the presentation. Okay, perfect. So quick introduction. So my name is Keith Dunlop. I work out of the UK as part of our European Engineering Lifecycle Management team, which encompasses both SimManager and Material Center. And the focus really for today, as Matthijs has said, is to give you a little bit of an interview or a little bit of introduction to SimManager and give you a principal focus on data management. There are two parts to this or these presentations. Today is really focused, as I say, on data management, and is expected to be the, if you like, the foundation for the next session, which is a little bit more process focused, building on the core capabilities that we'll go through today. Really, SimManager sits within an environment, I guess, generally known as SPDM, where SPDM is simulation process and data management. And as I say, today is very much focused on the data aspects. So think of SPDM really as being, I guess, the simulation environment or a simulation equivalent to PDM or PLM. So we're not dealing with design models here, but what we're dealing with are the analysis models, be they structural, thermal, CFD, acoustics, whatever is required in the analysis domain that complements the design structures that are typically existing in PDM. I guess in terms of validating, are we any good at this? Well, we've been doing it for 20 years, as you can see from the timeline that we have here. So SimManager is a proven solution in amongst a number of different customers in a number of industries worldwide. And we've also spawned a couple of other components or vertical applications sitting on top of SimManager, which includes SimManager specifically for Adam's car, and also a materials focused environment called Material Center, both of which working off the same underpinnings of the SimManager framework, which we'll talk about today. But I guess one of the things to bring out here very clearly is that SimManager as it exists today is not an IT framework, but is really has been evolved over the last 20 years to become something which is really a configurable application, which is, if you like, exactly the same piece of software used in all of our customers, but with specific layers that make it customer specific, whether that's related to how it looks or how it integrates with specific applications that they have in place. So as I say, a key focus for us is the fact that stressing that this is not a framework that you have to spend huge amounts of time and effort implementing SimManager at any customer site. It is really a standard framework with a lot of components exposed out of the box. And in reality, there's probably only three things that you need to do before you're up and running to a point where you're able to manage data in the sort of way that I'm going to describe today. And those three things are, number one, get the software installation, which we also provide all of the supporting software that you might need. So we include an open source database with Postgres, but if you need to integrate with the likes of Oracle or SQL Server, that's perfectly fine. We also introduce a web application server as part of the software delivery as well. So everything that you need is on one software install. Allied to that, once you have it up and running, you then simply need to define the if you like, the project definitions, project hierarchy that you want to use to store your own data. which will become a little bit more apparent as we move through today. And then the final part that you need is, of course, to set up the users, define the number of users you want, define their roles and their rights, which are really sort of profile or domain based within SimManager as well. So you don't need to set up the access rights for each individual user individually, but you can do it on a categorization of their role, their function, or their particular profile. So it's quite straightforward to get up and running. And the idea is that we provide a system and a level of functionality which you can then upgrade release by release without having to rework the configuration that you have put in place at the outset. So let's go through a quick look at some of the scenarios, and maybe this puts if you like, the use of SimManager in a little bit of context in the if you like, the environment of managing data. This is a fairly common view from a lot of our customers, that, you know, in any project you will have a set of goals at the outset of a project, and you'll do a whole bunch of work over a period of time and come out with a set of results. Now, to generate those results, you've got various experts working in parallel or in sequence at various stages of the project. A lot of them working in their own domains and working in, if you like, environments which are isolated to them. So everybody's got their own data and their own format stored on their own individual drive. That might be shared with others, but typically you end up with a lot of information collected for each of those users individually. There's a huge amount of communication, of course, going on between the different people involved, often via meetings, email, other sorts of aspects. So whilst the project is running, there's a lot of project knowledge already there. The difficulty comes whenever the project then ends. So once you've actually finished doing the work required and everything is reported and released, and you move on to the next activity, what you end up with is a huge number of locations where you've got disconnected information islands. And unless you are the person that generated the data or the person who worked very closely with them, it's highly unlikely that you're able to navigate somebody's shared drive, find a set of files in there and immediately know the context of that file, what it represents, who created it, and if it's the most up-to-date revision or if it's not. So what we're trying to do within SimManager is really to get an environment where, rather than having an environment with disconnected information islands, we try and pull everything together into one central repository, managing all of the data, but then also critically managing and hosting some of the applications that might be needed to process that data as well, all within one environment in SimManager. Now, one important thing to raise at this point is that pretty much everything you see, with the exception of CATIA, is a set of software tools which are MSC specific. It's important to stress at this point that SimManager is a very open solution. So in fact, a lot of our bigger SimManager users actually use a lot of solvers and a lot of preprocessors which are not from MSC. We are incredibly open in terms of the data types that we manage and also the applications that we integrate with. So don't think of SimManager as being something which is very much MSC centric and you have to change every part of your analysis process and the tool set included in that to fit within the MSC domain. Whilst we encourage that to the greatest extent, that's not a necessity for any SimManager instance. So that's if you like, a key driver that we have, so that rather than ending up with disconnected information islands, what you end up with is a set of information which is very well connected together and very clearly traceable to understand the, if you like, causality of information that you have on your desktop whenever you browse the content of any particular project. So this is something which we keep the data, yes, we keep a reference on how it was generated and who, but we also keep the traceability to understand how it was generated and what the inputs and outputs were to any particular process and any particular set of data. Now, today's focus is very much on the data management aspect. So really looking at the content that we have in here, but there is also the potential for improving the speed through which analyses can be done, whether it's standardizing, whether it's integrating processes, whatever else. And that will be, as I say, the focus for the next session we have coming up in a couple of weeks' time. So key aspects for us. let's start to look at a little bit of the content within SimManager and understand a little bit more about why we're doing what we're doing. So if I focus initially on data traceability or searchability, I mean, the numbers here are, sort of arguable numbers and will change depending on industry or how well you are organized at the moment. But typically, engineers spend too much of their time looking for data. And the goal for a lot of customers is to try and reduce that amount of time as a starting point. Part of that is providing more information to understand the context of the individual models themselves or the individual files. But part of it is also focused on things like increasing the amount of model reuse that's available. So rather than sharing information and replicating information, if you can simply store it once, manage it once, and then have everybody reusing exactly the same instance of that model, that's a significant benefit for most people, because you get transparency of if something has changed, if that data has been updated, but also you get clear auditability of where that information has been used. And if there's a problem with that file, it's always very easy to see who is affected downstream as well, because in a lot of cases, you don't necessarily know where data has been used if all of this data exists on local copies on everybody's desktop. And the final point, automation of data capture, is something we're really focused on in terms of trying to make life as easy as possible for our end users as well. It's all very well saying, yes, we want to standardize the way information is managed and information is stored. But often engineers look at that and say, well, that's just additional overhead for me. So I've got to manage the whole process of checking in and checking out data as I try and get through my daily work. And that's just causing me more and more delays in getting things done. Is there not a better way to do things? So what I'll show you today are a few different ways of getting information in and out, and some of the ways that we've got to minimize that additional work and try and make life as easy as possible for the end users of these applications. So this is, if you like, a starting point for us. Now, in terms of the data display, this is a view of the SimManager web UI as you see it here. So the actual server itself works as a network application. So basically all you need from a client perspective and an end user perspective is a web browser, and that allows you to be able to browse the content or import data or execute analyses all from a simple web browser, which I'll show you as we work through today. It's important just to talk very quickly a little bit about some of the information that's presented here, because this is in essence quite a simple model, but there's quite a lot of information being presented on screen. So basically all we have here is a Nastran input deck. It's a very simple box model, as you can see on the left-hand side. And the key file that we have is our model in the middle here, boxmodel.bdf, very simple file. Now, if you were to look at this on a file system, all you would see on a file system is that file name with maybe some information to say who owned it or who created it, and maybe a timestamp to say when it was created, and possibly, looking at a folder structure, you would know which project it exists in. So there's some information that I'm presenting here, which you could get from a file system as well. But there's a huge amount of additional information which we're capturing automatically, which you don't get from just having files sitting on a file system, which it would be difficult to interpret. So let's touch on them just a little bit more detail. So analogous to the folder system that you got, or the project structure that you might have on a file system, is our project structure within SimManager. And this is the second of the 3 points I referred to earlier when I said you need the installation media, you need the project structure, and you need the users. So this is if you like, the project structure in which data would exist. And you can decide how the project structure is, of course, created. You've then got the file format itself. So if you understand Nastran formats, you might expect a .bdf or a .dat file is a Nastran file. So in some cases, it's useful to know what the format of that file is. And we can, as I say, support pretty much any format that you have. We don't care so much what the content is. The important thing for us, which is analogous to a format, but is not necessarily a one-to-one link, is what we refer to as a type of data. So in this instance, I have set this particular system up to qualify this data and this input deck as being a durability input deck. Okay, it could be a strength input deck, it could be a fatigue deck, it could be a thermal analysis deck, it could be a CFD model, whatever way you want to define these. You've got a lot of flexibility in defining the types to suit the language that your users are typically familiar with. But in this instance, it's an input deck, which in this case is denoted as a durability input deck. There's then a few other bits and pieces that we need to work on. So the file itself is called boxmodel.pdf. That's the actual file name. The name at the top, however, is something which is slightly different. So this is what we call an item name. And this is, I guess, one of the important building blocks to define the structure of information within SimManager. It's not essential that we do this, but most of the data that you'll find it will have the structure of saying, well, there's an item, which is the general description of what this is. In this case, I've called it a box model, but you could call it, whatever it is that represents the actual structure itself. So in a lot of cases, you'll see some examples that I go forward. You might have some aircraft models where you'll have a wing or a rib or a spar or skins or ailerons or whatever. Okay, so those will be the names that are used. The actual name of the input deck is immaterial, because you could have multiple input decks that represent different instances or different representations of that box model that can coexist side by side. Okay, so that's one thing to bring out, is this general naming convention. So rather than searching on contents of files or some metadata which labels this particular model, the input or the item name is often the useful or a useful starting point. Allied with that is then what we call our variant. Now, for us, a variant is effectively saying, is this the baseline model for our box model, or is it alternative number 1 or alternative number 2 or alternative number 3, which may change depending on maybe the material it's made out of or some shell thickness or something like that, or maybe it's a different geometrical representation of the box. So there's lots of different ways that you might want to explore a design space and see, well, rather than starting with the model as given to me by the CAD engineer and then taking the materials and thicknesses defined by them, as an analyst, can I go and play around with a few other alternatives and change some of the structure to suit my particular environment and see if there is potentially a better choice that works for this particular environment or for this particular model. So that's really the environment that you want to present to your end users, where they've got a sandbox that they can play with independent of the CAD system or the CAD model or whatever the starting point might be. So don't think about SimManager as being somewhere that constrains you in terms of defining alternatives or doing design studies. It's actually something that helps you manage all of those alternatives and qualify them very, very easily. Then we get down to some other aspects, like things like the project phase, which you can set, the definition of the owner. In this case, I'm using the persona of Andrew analyst. I should have changed this to my name. And then, of course, we got some other aspects which relate to the security and access control, which in this case are the release levels, which I'll try and explain a little bit more as we go through the day. So those are, if you like, are the pieces of metadata around this particular file. Much richer set of information than just looking at a file itself. But the other part to mention here is a key aspect we've got called enrichment. We can set up rules within SimManager that say, if I input a file of a certain type and a certain format or whatever the rules want to be, I can automatically then launch other processes to generate additional information. So in this case, as soon as I input this PDF file, there's a rule that's set up that we automatically launch behind the scenes at some software from VCalab, who are a software partner of ours. We launch VCalab in batch on the server to generate a lightweight representation of this particular PDF file. So this CAX file and WCAX file and the XML data is all generated automatically behind the scenes. The user never has to say, go and run this particular process. And it allows us to be able to represent this view. So this is the CAX file viewed in the browser itself. So I get a 3-dimensional view, which is able to be rotated and manipulated, as I'll show you in a minute, to be able to see all the content of this particular file. So this adds, if you like, extra levels of information to the baseline model that we have here. It's especially useful for engineers or people who are accessing the data who don't have maybe a preprocessor to be able to show this PDF file in a 3-dimensional view. The same applies for CAD models or CAD assemblies. If you don't have the CAD system, well, you can simply see what the structure looks like in this three-dimensional view that we have on the left-hand side. So it's very, very easy to be able to enhance this data content by running tools like vCollab. The XML data that we extract out here is also then represented in the right-hand side in terms of the metadata to describe a lot of the other aspects of this model, which just in this case summarize the number of nodes and elements and load cases and things like that. But maybe it could be used to generate automated information based on quality of the mesh. You might want to have a quality report for the individual mesh itself to say, is it high, low quality, where are particular issues for this particular model. Something that users should do more rigorously, but typically don't because it's an additional overhead. And again, something we can run automatically. And a lot of customers use this enrichment process to do a lot of things in addition to what I show here. In some cases to do data conversion. So one good example of that is to say, if you've done a thermal analysis where you've got some temperature results and you want to then convert those temperature results into temperature loads on a structural model, often they have scripts in place to be able to do that automatically. Well, we can integrate those scripts and have this done as an automated process in SimManager so that as soon as the results of a thermal analysis go in, we can automatically generate the temperature loads to be applied to a structural model. So that's one key area that some users focus on. In addition to this representation that we have here, the other part I wanted to show very quickly was just the view of the audit trail or the pedigree of the information in the system as well. So in this instance, in SimManager, I've not only managed this input deck as our box model PDF file and referred it as being representative of the box model itself, I've actually used it and run an analysis. So from this input deck, I've got a Nastran result, and then from this Nastran result, I've extracted some key results from that, be they images, values, movies, whatever else. There's a whole host of information that you can extract automatically out of any analysis run that has been executed, and simply then provide that information as a comparison report. So this, if you like, at the top is the audit trail on the data. What you see below is an audit trail based on the process. So the green boxes are still the data items, but the blue boxes are the actual processes themselves. So the, if you like, the scripts, the tools, the applications that are running behind the scenes to be able to generate these key results from this Nastran result or generate this Nastran result from my durability input deck. Okay. So that information is captured automatically for any process that is run within SimManager. But if you've imported information from externally and you want to build these connections manually, we can also provide you a framework to do that as well. Okay, so just to break up the presentation and PowerPoint a little bit, and just to show you a little bit actually live on screen, let me give you a quick overview of SimManager just from a web browser. So I've just opened up a web browser on my local machine. This is now going to log on as a particular user, which gives me access to certain sets of data. Now, what I'm presented with initially is a summary of the information which is relevant to me. These are data items that I've worked on recently. These are, if you like, my models, my work in progress that I've currently got going on. And I can, if I want, decide how much information I present on my landing page at any point. So I've decided that I want to see some processes. I want to see the input decks I've created. I want to see the models I'm currently working on. You know, these are things that are relevant to the activity I'm doing now. So this, in this instance, is a set of data that I could simply say, well, if I want to see, you know, for example, my information on this normal modes analysis run that I've done, I can just click on that. It's a link that takes me directly to that particular model. In this case, it's a Nastran input deck for a Sol 103 analysis. For normal modes, where this is the model, as I said, the vCollab representation displayed on the left-hand side. So I didn't do anything to create this view, it's just generated automatically. Okay, so in this instance, this is all the data. Everything that I've referred to in the previous slide is all there. This is all the information that we have. I can see for this particular assembly, this is an assembly that we've created for the analysis model themselves. So we've got a set of loads, we've got a various number of components, some of them constraints, some of them where we apply different loads, some of them bolts, upper and lower flange are individual components. So I can see everything related to this, if you like, this assembled model from this view, or I can, as I showed previously, show it from the pedigree view as well, where I can then see for this particular normal modes analysis what the connections are between, these are the mesh models that were used to create the assembly. This is the input deck itself. This is the Nastran result that was created, where again, for this Nastran result, I also have a view of the results data, which I can also interrogate and look at the detail of that in this this lightweight representation, or I can take my OP2 file and go and open it in Patran or some other post-processing tool to be able to generate that data. But as part of the analysis process, I also generated a set of key results in here, which were, in this case, either movies or individual mode numbers, or sorry, frequencies at which we had our natural modes. So these are the set of results which have been generated automatically. Now, one thing is slightly different here from the previous view of results is that what we can see now is we've got a huge collection or a large collection of data for analysis information as well. So even though this is one result object, it can hold multiple files, 5, 10, 20, 50 files. We don't care. So you've got a whole host of files that are related to this particular result. Okay. What I want to do now is to show you something slightly, if you like, a slightly different view on the audit trail, but in this case, redrawing it from the variant itself. So in this case, showing all of the individual results that have been generated from all of the analyses. So for this product assembly, I had 3 input decks, SOL 101, SOL 103, and SOL 109, each of which getting a set of Nastran results. But then I can have a summary of all of the results, be they curves, as we see here, where we can toggle through various response curves, or maybe individual movies or individual images, things like that. So you can see the representation of the natural modes and the mode shapes very, very easily just by displaying those particular movies. Okay, so that's if you like, a very quick overview of finding data in the system for data that you're working on immediately, and then doing the analysis and audit on all that information that you see presented to you. Another way to do it is based on what we call our navigation tree, where within SimManager, you can create multiple hierarchical views of data in the system. Okay, so in this instance, I might want to filter on things which are particular crash simulations or NVH simulations, or maybe I want just my, just filter for geometry and nothing else. Or if I stick to the data view as I have it here, I'll see everything that exists irrespective of whether it's CAD data, as in this project, or whether it's all my CAE data in this particular project. So in this instance, we can see everything presented very, very clearly on screen. And if I want to, I can dive into individual models and look at the detail of that in this preview from the navigation tree very, very easily. So this allows me to be able to browse through the content, present it in a way that's familiar to end users, and then allow them to be able to work on that data from that point. Now, I said earlier about useful information to manage about data, to allow you to be able to find it at some stage in the future. At various instances, you probably want to run various searches across the database. So I'm just going to run a quick search on the top right-hand side. We've got a general sort of Google type search, which searches across the database, across every aspect. So in this case, I'm just going to search for the string hood everywhere in the system. And in this case, I can get matches across the database in multiple projects for the instance of this particular label, which I can then go through and filter down and look for data specifically in individual sub-projects where maybe I want to look at certain items and break things down into individual types, maybe filter it based on when it was created or who created it, things like that. But if I decide, well, this looks like it's the piece of information that's relevant to me, I can then just click on that, open that, and we can see the representation. Again, here it's design data or CAD data rather than simulation data. But we can see very clearly that from this particular CAD model itself, we've then got an audit trail that allows us to be able to track and trace where it has been used. So from this design module, we built this specific mesh. So this is our mesh model that we have here, and it's been used in a particular crash analysis where we've got this structure that has been built up from a whole series of input decks and everything merged through there to get our results of our crash analysis with the various curves, images and movies for the crash analysis itself. So you can see the result of the crash analysis just by following this audit trail from the design model through the line of what was done by whom very, very easily to generate the view of the results data that we see here. And for any user, if they want to see that information in a bit more detail, they can jump into the Nastran result itself and then have a more in-depth look at the results file itself and actually play some animations of the actual crash itself, maybe taking sections and things like that, whatever is appropriate on this particular CAD file. Okay, so that's kind of a very quick run through of the view on the, if you like, the data navigation, the audit trail, navigation views, searching, things like that. Very, very quick analysis of what's been done. However, we've got data in the system, but I haven't shown you yet how we get data there. Now, there's a lot of ways to do this, but let's just jump to my sort of data test area where I've got an empty project here where I can show you some of the ways of being able to get data into SimManager. So in this instance, probably the best thing to start with is to look at our import process. So one of the things we've got is we've got a various numbers of tools to be able to say, well, we want to just import some data or maybe do an import and simulate process. So this is if an import and simulate process is effectively saying, let's use SimManager and the web UI as the portal for submitting jobs to your HPC environment. Okay, so you might have an HPC environment with, I don't know, Slurm or PBS Pro as the queuing system sitting on top of that. Fine, no need to change that. All we would do would be to have SimManager connecting through to that queuing environment, which would allow us to then use SimManager to control the import and simulate process. So in this instance, running import and simulate, what I can do now is to simply say, well, for this instance, I want to select maybe some files that I've got on my local desktop, pick those files, and then import them into SimManager for the analysis. So if I pick this box model BDF file, this is just the file that I have as something I created externally to SimManager, something maybe has been provided to me, maybe something I've worked on individually with a preprocessor offline, but I've got this run ready analysis deck. Now in this PDF file, I've got a bunch of information in there. So there's a host of information. If I just open that and show you the content, what we've got here is, for those of you familiar with Nastran, everything that Nastran needs is really from line 20 downwards. But what we've done is to add a little bit of extra information above that. And you can have processes internally, or you can customize preprocessors to do this. This is really a little bit of extra information that fills in some of the missing detail about how you want the analysis to be run, and also what you want this particular model to be called. So in this case, this is the item name that will appear. This is the type of the object that's defined. Those are the project phase we're working in. Those are the key things that that need to be put in to be able to fully qualify this particular file and describe what it is. If you don't have the information here, well, it's just a matter of filling it in from these various drop downs that you have and the menu screens that you have in this particular form. But from this screen, we can then go through the process of saying, having uploaded this file, I can now decide, do I just want to upload the file? Or do I want to automatically then chain a solve process to it to run Nastran? And then I can also define which version of Nastran I want to use and things like that, how many CPUs, how much memory, etc., etc. Once the analysis is done, do I then want to do some post-processing automatically? If so, what inbuilt batch processing do I want to do? And then finally, for the post-processed data, do I want to generate a report? So from this one screen, I can chain together a whole host of information. And the only thing I'm submitting, the only thing I'm importing is the BDF file. Okay. So this now allows me to be able to go through, so box model exists. So let's say box model. I'll go through the process of creating the new example that we have here. So let's say, submit that. So this now launches a process in SimManager that, having submitted this analysis to be done, I can then just leave and go away and log off and go home, and the analysis will run in the background to do whatever needs to be done. But this is just something we'll walk through and leave it just running through. This is actually solving the analysis itself, where from my browser, we put the file on the server. From the server, we then connect to the HPC, run the analysis. And at the point where the analysis is run, we then automatically retrieve the results back into SimManager. So there's no necessity for the user to move those data files for the results. And as soon as the results exist, we can also then launch some post-processing activity to be able to generate the images, the movies, the values from whatever the tools are we're running behind the scenes, which might be Perl scripts, they might be other applications to generate that particular data. Okay, so in this instance, you've got all of the data running, you've got all of the systems running behind the scenes. And if I want to, at any stage, I can jump to look at what is being created already. So in this case, we've got our box model example with a durability input deck for that. And I can simply click on that and go and see that data existing in SimManager. So you'll see here that all we have is our BDF file. There is no image on the left-hand side because we haven't started generating that yet. The focus for the process is do the analysis first. Whenever that's done, come back and do the enrichment of the input deck and generate all the other information. But as soon as results appear, and now the analysis job is finished, so results are now available, then they appear automatically back in SimManager. Similarly, any key results are generated, they're automatically put back into SimManager as well. So here you can see very, very easily how we can import data simply by dragging and dropping files or indeed folders of information into SimManager. Okay, and we've no limit on 2 gigabytes for the data sizes themselves, and we've got asynchronous upload of data. So if you need to move your machine from one part of the network to another, we can pause the upload and then go back and restart that at some stage in the future. So there's lots of functionality. We understand that data files that analysts typically use are very large, so we need to be able to address that particular environment, and we have all of this information manageable in here. So that's one aspect of how we can work with data in SimManager. Now, another thing I want to touch on very quickly is just this idea of saying, well, I've shown one method of editing this file or importing this file from some other environment. What if I want to edit this file? So let me show you another way to work with SimManager, which is in this case, using a preprocessor and using a sort of an inbuilt or a referenced application from within SimManager to do some data editing. So data editing is one simple aspect, but you could link in any application at all. So this might link to a preprocessor or some other application. I can decide if this is simply a revision of this file that we want to work on. In this case, I'll say, yes, that's what I want to do. If I said no to that, what it would do would be to create a V2 of our box model example. Okay, but I'll say is revised, yes, and this will now show you how to do an edit or an update on a particular file. So this is going to now run an application externally, pass the data out from SimManager to my desktop, and then launch the application that will be running to edit the file itself. Okay, so this is part of an understanding of, well, what particular file do we need to run this? And in this case, we're automatically launching Notepad. So you can see, analogous to the way we ran the Nastran example, which is a process running in SimManager. We're running a similar process, but we're simply saying, from SimManager, I want to launch an external application to edit this particular file. And then whenever this is finished, we then need to re-import the data back into SimManager. So in this case, I'm just going to make a very small change to increase whatever the shell thickness for this particular material. Save that. And then whenever we close this, we will, in this instance, automatically upload the data from my desktop back into SimManager. So again, there's no need for a user to say, well, I've made the edit. I now need to go and check that particular version of the file back in again to create revision 2. That can be done automatically for you. So depending on how you want the behavior to work, in this instance, I've said for the text editor, upload the result automatically. You may, for some applications, want to do this in a more manual fashion. So you have the options to do that as well. So in this case, we've got our new BDF file. If I just click on that, you'll see that now we've got our 0.87 as our new thickness for that particular shell. And the revision number for this particular file is revision number 2, which can be visible from here. It can also be visible from the revisions tab that we see here. So I can see revision 1, revision 2, and have a good understanding of who created them at what particular time. And if I want to, I can actually run through a process of comparing those 2 files as well, either looking at information about when they were created by whom, or looking at the individual file differences themselves. So I might want to just do a text comparison between file number 1 with a thickness of 0.075 and file number 2 with a thickness of 0.087. So there's a lot of functionality there to help you do things. So that's, if you like, option number 2 for importing and editing data. But before we leave this, let me show you a third option, which is really where we're looking at potentially working in an environment where people are saying, well, actually, what I want to do within my operating environment is to just work on my desktop, editing files. And then, whenever I'm finished editing those particular files, what I want to then do is to upload that data directly into SimManager. Okay, so in this instance, I might be looking at, maybe this box model with a hand-edited file on my desktop. So I'll just change the variant name to V8. So let's change some text in here to say variant. Okay, and I can then say, right, this is something I've worked on locally. I just saved that. This is kind of, for some of our users, this kind of environment they want to work on, that if they're looking at a pre-processing model or something like that they've been working on during the day, they don't want to have to go into the web interface. They don't want to have to, log in, upload things like that. They just want to run one command from a command shell and then say, take the data that I'm working on, either as a file or as an individual folder, and go and push that from my client machine, from my Windows machine, into SimManager. Okay, so in this case, we've got a saved password for user number 1, so I'm automatically logged in. And here you can see that this is the summary of the import process that we've got within SimManager. So that data that we've been editing by hand here, we've just pushed it in. I can forget about it now and go home. It's now in a central server, and anybody who has the right to go and see it and has access to that can go and see that particular data. So if I look now in the data test box project and go and look at variant number 8 of the box model, you will see that it all exists in here. Okay, so if I simply go to the Navigate tab, and if I look at the test box model, in here I've got my items, and I've got a series of variants, and we've got variant number 8, which now exists. So this is the one that I've just pushed in. And in this case, we've got the actual input decks themselves, and you can see there's the text that I included in that particular file. So a very simple file example, but it gives you a good indication of what's possible within SimManager, and different mechanisms and different ways of being able to get information in and out of the system. So a key part for us, just going back to the slides now, is collaboration. I've shown you very clearly how data is represented. I've shown you how information can be put in by any user at any time with different methods of doing that. And the whole idea is to make sure that all of that data from SimManager is collected into one central repository. So irrespective of who you are and where you sit, and in the current environment we're in with lots of people working from home, this is perfect for this kind of environment. So rather than relying on email or shared directories or things to share information, you can push information very easily from your desktop into a central server, or edit data on the central server directly and provide that out to other users within your organization very, very easily. There are, of course, alternatives available, and some of these are already probably used by you. So whether it's shared network drives, huge reliance on email, moving large files around as attachment, whether it's modifying PLM or PDM to take if you like, a design environment, which is great at managing the evolution of CAD models and CAD assemblies, but needs quite a degree of customization to work with the range of data files, range of content, and large data files that are in the place with simulation data. And that's quite an expensive thing to do. You've got the likes of SharePoint, Google Drive, which are great at simultaneous access and simultaneous editing of individual documents, but kind of limited, or have the same sort of limits as to, how do you understand the pedigree or the supplementary metadata about files? Same problems that you have on shared files and shared folders. And then you've also got source code management tools like SVN, Git, and things like that, which is great for replication of data, but is it necessary in all cases? And is there also then the traceability, the audit trail, the understanding of what data was generated by what else? does that come through in the same level of clarity in tools like that? So there's a huge amount of issues and questions to be addressed, which will change customer by customer or implementation by implementation. But there's lots of tools that we have in place to be able to give you key additional functionality. Some of that is related maybe to how do you reuse data, but some of it is also potentially how to delete data that you're collecting or generating. So we've got very robust tools that support auto deletion. And with some of our bigger customers, by switching a lot of these on, it's actually helped them reduce their data storage by about 60%, which if you think about the cost of managed storage, that's quite significant. You've got all sorts of aspects of security, so that not only relates to access control, so who should see the information, but you also got to add the level of who should see information at what level. So if there's data that's been experimented on, you probably want to have a small number of people accessing that data, but anything that's frozen, released to a project, that's probably open to a broader end user community to get access to that data. And again, as I touched on at the start, you will have multiple representations for individual parts. You will have strength models, you'll have vibration, fatigue, acoustics, thermals, and they will also have dependencies on each other as well. So the example I gave previously was you probably would do a thermal analysis to get temperature loads that then get applied as loads to a structural model. But then you've also got a lot of other components that are potentially not part of the product itself or supplementary to the shape of the product. So for crash analysis, a barrier or a crash test dummy, it's not something which is part of a car. Similarly, loads, similar materials, individually managed, slightly different from the structure, but can be managed individually by SimManager as well. And then think about the non-value add activity. How do we enable users to get the most out of this kind of environment? A lot of people will look at it as being an overhead, but ultimately what we want to try and do is to take away as much of that overhead as we possibly can through any implementation that we've got. So in quick summary, key focus areas for today were data management. How do we store, manage? How do we reduce this exponential increase in the volume of data that people generate? And how do we qualify the information as being high quality, low quality, appropriate, something we want to keep, something we want to delete? And ultimately, in a lot of cases, how can we reduce the cost of managed storage through rules deletion policies? We've got traceability, clear, unambiguous audit trail of how data was generated, and of course, efficient collaboration with other users in the organization. By having everything stored on a central server, you have a single point of truth for all of the data that you generate. So it becomes immediately customer data or company data rather than individual user data. But still, we provide lots of ways to access that data, either from a very simple web-based environment, which needs no software installed on the front end, through to having some other components, maybe using REST API, connecting specific software with SimManager in the background, or maybe providing remote visualization, extending on from what vCollab provides to provide true remote visualization using VNC and typical other and DCV tools that might benefit you in terms of visualization of data on the server without ever moving it from the server itself. And then finally, access control and security. It's probably the most valuable data that you've got. So how do you manage it? How do you secure it? How do you control it to make sure that only the right people get access to that data, but making sure that the data can be shared very, very easily with anybody in the end user community. I will stop there because I realize I'm 10 minutes to go to the end. So possibly now is a good time to take some questions if there are any.
Yeah,
that exist.
Perfect. Thank you very much, Keith, first of all, for your contribution today. I think it's a really good entry point and a good overview for people who just get into the idea of data management with simulation. We've got a couple of questions that came in during your talk. So some of them have about the same idea. So I'll try to rephrase them a bit so we answer multiple at the same time. So first question would be from a starting point. So if you would like to start working with SimManager, or if you would like to implement SimManager, if you would like to set it up for your environment or your organization, would you have any advice on where to start and what kind of effort it would take?
Okay, so data is always the starting point. Now, different customers some customers will focus on looking at taking legacy data and using that as the starting point to import data into SimManager. Because for some, it's if you like, trying to get a focus of understanding how they would represent their own existing data in SimManager. So that's probably a good initial discussion to have with us to understand, well, you know, for the way you work at the moment and the way you organize your data, you know, how can you configure the data model in SimManager to suit what you do? Now, whenever I say data model, don't get too concerned. So what I'm talking about here, but I'll keep it with this. What I'm talking about here are things like the labeling of the types of data you have. So underneath the standard schema that we have, that we say input deck. Well, an input deck is a standard thing we have. Well, okay, great. But are there ways that you want to sub-define your input decks? Okay, or are you happy just putting everything in one bucket of input deck and working from there? So some of it is starting with a conversation with us to understand what's the type of information you have, what's the type of data that you've got. But really, you know, the whole focus for us is to say, well, don't be too scared about, you know, experimenting a little bit with SimManager. It is quite easy and straightforward to install the software and get started. I would say that, you know, our engineering teams and our services teams have a very good experience of implementation in a wide range of customers. So it's probably useful to have a conversation with us initially to try and get a boundary on the scope of what you might want to do, and then help define the various stages you might look at moving forward. But in terms of the general framework, every SimManager instance comes with a development server and a production server. So even if you decide to experiment a little bit and mess around with the configuration in the development environment, if it all breaks and you get to a point where it doesn't really work, well, you can either throw it away or start up another virtual machine and, you know, work with another instance of that and then go from there. But we run standard training courses. There's quite a range for different users and user types, whether it's IT configurators or end users. So, you know, a combination of talk to us on the technical aspect, let's look at your data, and then do a little bit of training, and then move from there.
Yeah, and if I may just comment on that as well, those of you that are listening that have MSC One available, SimManager is in there, and most of the SimManager courses are also available in the e-learning environment for MSC Software. So you can, if you would like to get introduced to it even more, you can have a look at it there. But of course, don't hesitate to pick up the phone or write an email to us and contact us with your question. So let's switch to another type of question, maybe for those who are a bit more, I would say, familiar with data management. People, for example, that are already using PLM products like Teamcenter have a question: in what way would it make sense for me to start working with SimManager?
So we've got a lot of customers that use Teamcenter as a PDM or PLM environment. And use SimManager as the simulation environment. And we've got a number of people who have presented at various NAFEM's SPDM conferences. So those papers are available to go and look and learn from what they've done. But typically, in terms of the integration aspect, what we're looking for in terms of, if you like, the handshake between the two is to say that, you know, the Teamcenter environment can manage the PDM data. And at the point where you want an analysis to be done, you do an export of the CAD structures from Teamcenter into SimManager, and then manage all of the simulation process within SimManager. At the point where you then generate a report, and then you have something which needs to be shared back to the PDM environment, you can then simply share a report or share the summary of the analysis results back into Teamcenter. So for a design engineer, maybe looking within Teamcenter, they can simply say, okay, for this CAD assembly, what reports exist? So they see that association immediately side by side. But if they want to see the detail of what's in SimManager, they can just click a URL and see all the information within SimManager directly from that URL. Because all of these items that you see here are all, you know, accessible from a single URL, which I can actually even just, you know, from where I am now, click on this little item, and that's now copied a link that I can post an email and send off to somebody to give them a little bit more information, or give them a shortcut to this specific piece of information if it's of interest to them.
Yeah, makes absolute sense. I think the question I've answered is, if not, let us know in the Q&A section. Maybe a last one to finish off with. What is the minimum team size to start working with SimManager? So do you have any advice on, for example, different skills of organizations you've worked with in the past, or any things you've experienced?
So I think the smallest group we probably work with at the moment is a team of about 4. And then the biggest is probably looking at somewhere in the region of 300, 400, 500 concurrent users.
Yeah, so for engineers working with CAE technology.
Exactly.
Yeah.
So I mean, one of the biggest reference account that we have is BMW, probably, I would say, in terms of volume. So they execute somewhere in the region of 2,000 full vehicle simulations every day. But the complete other end of the scale, we have customers of teams of 4 or 5, something like that, who use SimManager in a very different way, and it's much more focused on some of it is productivity gains in some sort of non-value add stuff that they want to capture, but some of it is very much focused just on data management, data sharing, data accessibility. If there are customers that they work with, maybe they want to get to a stage where they actually give some customers or some partners access to some projects on their in-house SimManager server. So actually an external partner can log in via VPN to their particular site and start pushing data up to their project folders on their SimManager instance. So yeah, it's 400 to 500 and lots in between. But yeah, four users is probably, I would say, that I think the smallest that I can think of that we have. That answer your question? We've stopped.
No, sorry.
Nope.
My mic was still on mute.
I thought
It's a classic mistake.
I thought we'd run out.
No. It's my bad. So I was saying that I can perfectly imagine, if you're working with a team of 4, that it makes sense that you start off with a shared folder and then sharing your files through there. But good to hear that you've also encountered people working with SimManager when they're a team of 4, where they still enable the technology that SimManager allows and the success factor of SimManager in the organization.
Yeah. And a lot of it for a lot of people is down to this. It's this understanding of saying, well, can you go back to a folder that you worked in 1 year ago, and be clear and unambiguous about what's in that folder?
Yeah.
It's always interesting when we work on data migration activities with some customers as well. Just when you start to look at, the naming of files, things start off quite nicely structured, quite well done.
Final part.
Exactly.
Finalist part.
Final part.
The real final part. So, okay, thank you, Keith. There's still a couple of questions that are open. We will send you a follow-up email with our details, so you can contact us afterwards as well. We hope we've given you a good overview from a beginner level and the data management part for SimManager. I invite every one of you to join us the 11th of June as well for the second part of this 2-series workshop, which is going to be more focused on process. For now, I wish you all a very pleasant day and hope to see you in about 2 weeks. Thank you very much. Thank you, Keith.
Cheers.
Cheers. Bye-bye.